Okay, let's start. So, hello everyone. Today, our last meeting during our premier session of Kraków Graph Academy. We will back around September, but today we have a special guest from Neo4j, specialist of GRANDstack, William Lyon. Hello, Will. He told us about GRANDstack, the most popular technology stack in which we use among other GraphQL and Neo4j. So if you have any question to Will, please ask using microphone or put text into chat or ask after collection. So Will, floor is yours. Good luck.
Great. Hey, everyone. Yeah, so in this talk, I guess I'd like to talk a little bit about GRANDstack and the different components, GraphQL, React, Apollo, Neo4j Database. But then I'd also like to show some hands-on bits. So maybe I'll go through a few slides and talk for a little bit so you have an idea of what GRANDstack is, how we use GraphQL with Neo4j, this kind of thing. I probably won't cover too much focus on Neo4j, but just on all the different components and how they fit together and how you use them to build applications. If you're looking for the slides, you can find them there, dev.neo4j.com/krakow-graphql. So with that, if you don't know me, my name is Will. I work on the developer relations team at Neo4j. The best way to get a hold of me or see what I'm doing is probably on Twitter, I guess. That's my Twitter handle there. And then also my personal site where I have a blog and newsletter that I publish. And I should add on here that I don't have on these slides is I also host the Neo4j podcast called graphstuff.fm along with one of my colleagues, Lou. So if you like podcasts and you like graphs, graphstuff.fm might be a good podcast to check out as well. That's kind of a more recent project for me that I like doing. So we're going to talk about GRANDstack. So GRANDstack is this full stack development framework for building applications using GraphQL, React, Apollo, and Neo4j Database. GRANDstack.io is a good site that has links to resources and documentations and some starter projects, which we'll take a look at today as well. So first of all, maybe let's chat a little bit about GraphQL. If you're not familiar, just to kind of set a bit of a baseline. So GraphQL is an API query language and a runtime for building APIs. So with GraphQL, we're not talking about querying a database directly with GraphQL. It's about building that API layer that sits between the database and the client. So with GraphQL, we have a strict type system. So we define the types, what fields are available on the types, and how those types are connected. That's where the graph in GraphQL comes in, because with every GraphQL API, we have these type definitions that describe how the types are connected. Then at query time, the client can ask exactly for what data it wants from the data graph that you've described with those type definitions, the schema. Those type definitions become the schema then for the API. And then the result is exactly what the client has asked for. So the result matches the shape of a GraphQL query or mutation, which is a write or update operation. But we'll talk about that in a second, that distinction. So then if you're a little bit familiar with Neo4j, so Neo4j is a graph database, a database management system specifically. So it's interesting to compare Neo4j and GraphQL because we're going to be talking about how we use those together. So Neo4j, we use a data model called the property graph model. So we have nodes, we have relationships, we have properties, those are the attributes on nodes and relationships. We use a query language called Cypher to work with Neo4j. So you can think of Cypher as like SQL for working with databases, but specifically for graph databases. And then there are lots of interesting graph analytics, data visualization type things as well that we can do with Neo4j. So if you see this diagram in the top left, that's kind of an overview of the Neo4j graph platform. You have kind of on the left side of the diagram, you have tooling for developers building kind of transactional applications, right? So I'm interested in building an application that is serving a website, a mobile app, something like that. But then on the right, we have more of the data science tools where it's maybe about more ad hoc exploration and analytics, maybe machine learning, AI, feeding into a machine learning pipeline, that sort of thing. So there are lots of interesting use cases kind of across those two spectrums for Neo4j. Because we're talking about building full stack applications, we're more over on the left side of this diagram where we're talking about like graph transactions, a local traversal through the graph. So starting from a well-defined starting point, traversing the graph, rather than running some algorithm like PageRank or something like that that touches the entire graph. Now compare that with GraphQL, which we said is an API query language and a runtime for building these APIs with a type system and modeling your application data as a graph. So important to note that GraphQL is not a database query language, very much about building that API layer between the client and the database. But GraphQL is backend agnostic, so we can really use any backend system to resolve data for a GraphQL API. It's not specific to graph databases. It's not specific to Neo4j. In fact, GraphQL was created and then open sourced by Facebook for some of their internal systems. But when we combine Neo4j and GraphQL, we have a lot of interesting benefits. So one of these is that we have a type-safe API layer. So we're able to take the type definitions and the type safety from GraphQL and through the API, apply that to how we interact with Neo4j. Now, Neo4j as a graph database is optimized for traversing a data graph. So traversing from nodes to other nodes that they're connected to via relationships, which is often the type of nested queries that we end up writing in GraphQL. So you think of Neo4j as an efficient backend for a GraphQL API. And then there is a Neo4j GraphQL integration, the Neo4j GraphQL library, which really helps you get up and running quickly, which we're going to talk about in a little bit here. So let's look at an example. This is a public GraphQL API. I'll drop a link to this in the chat. Maybe there we go. Oh, and also drop a link to the slides. dev.neo4j.com Krakow GraphQL, I think it is. Yeah, drop a link to that in the chat as well. But anyway, so here's our, let me zoom in a bit. That's big enough. So here's our GraphQL API. This is a tool called GraphQL Playground, which is kind of like a query workbench for GraphQL. And one thing we can do off the bat here, if we click on the Docs tab, is we can see the entry points for this GraphQL API. So we have queries and we have mutations. So queries, these are read operations, and mutations are writes, like updates, creates, deletes, these sorts of things. So one thing that's really nice is we can immediately explore the data that is available in this API. So it looks like we have an API with movies and actors, directors, similar movies, this sort of thing. So this documentation is generated from a feature of GraphQL called introspection. So any GraphQL API that's running, we can send an introspection query that is basically a special type of GraphQL query that says, hey, show me all of the types, all of the data available in this API, and then we can construct this documentation. It also means that if we look over on our query here, and I have the last query that I ran that's already constructed, so we'll look at that in a minute, but I can have like tab completion so that I know what fields are available, which is really nice for adding developer tooling. Okay, so here's this GraphQL query. We're starting with the directors entry points, and then we're passing in this filter argument that says find directors named Robert Redford. And then this part of the query, this is what's called the selection set in GraphQL, where I'm specifying how I want to traverse through the data graph. And that's this sort of nested structure. So I'm saying for every director named Robert Redford, find all of the movies that they've directed, and then for those movies, find similar movies. So this nested structure is really, you can think of it as a traversal through this data graph. And then I'm also specifying the fields that I want to be returned. So I'm saying return just the director's name, bio, and then traverse to the movies that he's directed, give me the title, find similar movies, but just return the title. So as I add fields, so let's add a URL. So we have a URL for the director. Now you can see that field is now included. So the response exactly matches the shape of the selection set. So you can see that if I were querying this from an application, maybe like a movie search application or something like that, I'm only going to bring back the fields that I'm showing in the view of my application. Okay, so that's a quick look at GraphQL. Let's talk about comparing and contrasting GraphQL and Cypher, because I think this is a common question that comes up. Well, both Cypher and GraphQL are working with graphs, querying graphs. When do we use one? When do we use the other? And in what context? So for this part, we're going to use a data set that I've been working with that I think does a good job of showing things you can do with graphs. And that is what I call the news graph, but it's data scraped from the New York Times API. So this is the most popular news articles along with what topics they're about, who wrote them, but then any of the entities that are mentioned or referenced in the article. So is it writing about an organization like a business? Is it talking about a person? Is it talking about a specific geographical region? These sorts of things. And the code for this, is, as well as the import and the GraphQL API, is linked here on GitHub as well. So anyway, so that's the data set we're going to use. But let's talk about Cypher and GraphQL. So Cypher, we said, and we'll look at some examples of Cypher in a second if you're not familiar, but we said that Cypher is a graph database query language. So it's declarative. We use this ASCII art pattern matching notation to describe the graph patterns, like a subgraph, something like that, that we want to work with. And then we declaratively say, okay, find that pattern, and then return a piece of the subgraph or create this pattern in the graph, things like that. So we have all the functions that you would expect of a database language in general. So things like aggregations, math functions, database operations like creating indexes, and even data import for pulling in like CSV files, things like this. But then because it's specific to graph databases, we have lots of graph specific operations like variable length path operator, node and path functions, these sorts of things as well. Now, if we compare that with GraphQL, which again we said is a query language for APIs, we have this type system that describes the data available, that defines the data graph, and we're treating our application data as a graph. We can use this with any backend, and oftentimes a GraphQL API will federate data from multiple sources. So we'll have one unified API that then on the back end is fetching data from a database, from another API, this sort of thing. And we do have, similar to the idea of a traversal in Cypher with these graph patterns, we have a similar concept in GraphQL, which are these nested traversals to the data graph using those nested selection sets that we saw. So let's look at some examples. So going back to our news graph with articles, if in Cypher we want to say, show me all of the articles that you have. We write a match statement. So match says, go find this pattern in the graph. And then we write this ASCII art notation to define the graph pattern we're looking for. So we have these parentheses around article. So that's saying find all nodes with the label article and bind those to the variable A, and then just return them, and we get back a bunch of nodes. In GraphQL, we can do something similar. So we would use the articles query field, and we say, for every article you find, give me the title and abstract. Now, if we want the 10 most recent articles, well, in Cypher, we have ordering functionality. We have skip limit functionality as well. So here we're ordering by the published date and returning the most recent 10 articles. GraphQL doesn't have this sort of concept of ordering, pagination, skip limit, doesn't have that built in to GraphQL. It's kind of up to whoever's building the GraphQL API to implement this. But we can handle this sort of logic through field arguments in GraphQL. So here we're passing in the sort order and the limit. So order by published date descending, give me only 10 results. Okay, so what if we want 10 results and their topics? Well, now we draw in Cypher a more complex graph pattern. So this is a little more complex because first we have to find the articles and then only get the top 10 most recent articles. Then we do an optional match because all these articles may not have topics and we still want to return them. But the idea here is we extend on to this graph pattern to now include a relationship. So you can see we have this has topic relationship with kind of like drawing an arrow. So this is saying find the article and then follow these outgoing has topic relationships to the topic nodes and return the articles and the topics. And in GraphQL to do this, we would add this nested selection here in our selection set that says, go to the topics. Well, this is an object array field. So topics resolves to an array of topic nodes in GraphQL. And I'm saying, okay, bring back the name for all those topics. Now, if we want a bit more complicated traversal, so now all the 10 most recent articles, their topics, but now also articles that are connected to those topics of the 10 most recent articles. Again, we just in Cypher just add on to our graph pattern using this ASCII art notation. And in GraphQL, we just add on to our selection set. So now we go from the topics, now nesting into the articles selection to bring back the title. So articles resolves to an array of article nodes, and we need to have a selection from that article node or article object to say, just give me the title. Okay, so far we've been able to express things in Cypher and GraphQL. What if we have some more complex logic, like show me recommended articles? So there's lots of ways to approach this. In Cypher, it might be something like this. So if we're looking at an article, find similar articles, maybe defined by overlapping topics or author or geographic region. So if I'm reading an article about Poland, maybe I'm interested in other articles about Poland, that sort of thing. And you can see here's the initial article we're reading, and then traversing through the author. So what are other articles the same author has written? You might be interested in those. Here are other topics. You may be interested in articles connected to the same topic. So we can express that in Cypher. In GraphQL, though, we don't really have this concept built in of expressing these sorts of more complex graph traversals. Now, we could certainly add this functionality to a GraphQL API, where we're adding this logic in the GraphQL server, but that's not something that's really built in to GraphQL. Okay, so hopefully that gives some context of what are things we can do in Cypher, what are things we can do in GraphQL, what that looks like. Let's talk about we're ready to build a full stack application. Maybe we have our news data in a Neo4j Aura cluster, and we want to build a React application front end to take advantage of that data. Well, we don't want to just expose our database publicly and have anyone writing arbitrary Cypher queries against it. Instead, we want this GraphQL API layer that sits between our Neo4j Aura cluster and our React application. So maybe we deploy this GraphQL API as a Lambda function on AWS. There's lots of different ways to deploy a GraphQL API. That's a fairly straightforward and scalable one. So now we have our React application on the front end that is sending GraphQL queries to our GraphQL API. That GraphQL API has the logic for generating the Cypher queries to talk to our Neo4j Aura cluster. So it sends Cypher to the database, data comes back to the GraphQL API, and it sends data back to the client. So at a high level, that's kind of the architecture we're looking for. But then that kind of begs the question, okay, well, how do we build these GraphQL APIs? How do we build a GraphQL service? At a high level, and sort of starting with a sort of naive approach, or like the standard approach, without using any like database integrations or GraphQL libraries, what we do is we define GraphQL type definitions. So what are the types? What data fields do they have? How is that data connected? Then we implement what are called resolver functions. And this is where the data fetching logic lives. So resolver functions know how to actually go out to the database or the data layer, some other API, to actually fetch or persist the data that we're working with. And then we serve a GraphQL endpoint using a GraphQL server. Something like Apollo server is a really common way to do that. But basically what that's doing is it's taking an executable GraphQL schema, attaching that to the networking layer. So to handle the incoming HTTP responses, or HTTP requests, execute that GraphQL operation, and then send the data back is what the GraphQL server is doing. Okay, so what are type definitions? Well, we typically use the GraphQL schema definition language to define these. So SDL, the schema definition language, this is a language agnostic way of defining types in GraphQL. You can also define these programmatically, but SDL is nice because it's not dependent on any specific language. You can build GraphQL servers in pretty much any backend language, and SDL gives you something kind of portable between GraphQL implementations. Here's kind of the signature of what a GraphQL resolver looks like. This is JavaScript from the Node.js GraphQL implementation, where you're basically creating a map or an object that has a whole bunch of these different functions. And inside each function, you may be checking like an authorization header. You might be querying a database. You might be validating the response that comes back to change the format or something like that, and then returning results. And resolvers are called in kind of a nested fashion. Here are two examples. So the one on the left is just a single resolver where we're querying a database and parsing the results and sending that back. But on the right, we have several different resolvers where we are calling kind of like an ORM type API. And on the right, this is for like a conference API where I have conference sessions that are in a room, they have a theme, and then I have recommended sessions. And these resolvers, these are called in a nested fashion. So we typically start with the query field resolver. So those are the query field are the entry points to the API. So I'm searching for a session by keyword. Then I go to my ORM API, say, hey, find some sessions. And then those sessions come back to the GraphQL server. And now I say, okay, go back to the ORM layer and find what room it's in, go back and find out what theme it's in, and then go back and find other similar sessions. So you can see if I request all of these fields in my GraphQL query, I'm going to end up calling these resolvers in a nested fashion, kind of waiting for the first one to come back. And that could potentially generate a lot of backend requests to the data layer. So this is called the N+1 query problem, where oftentimes we end up making multiple requests to the data layer for one GraphQL request, which is something we want to avoid because that can have performance implications. But we'll talk about how to address that in a minute. So this naive, we'll call it the naive approach, is like the simplest way of thinking about things, I guess, is to basically just take a Cypher query, stick it in a GraphQL resolver, use the Neo4j driver to run that Cypher query and return the results. And this works okay if you have kind of a single query that you want to expose. So if you have a not very simple schema that you want to expose, and you're not doing things kind of in context of a more complete application, I guess. And this is what we do for the Neo4j community site. So community.neo4j.com, at the top, there are these activity feeds that show like popular blog posts, popular community projects, new developers that have been certified. There's one Cypher query that queries what we call the community graph, which is a Neo4j instance that has data about what the Neo4j community has been up to. It runs that and then returns that JSON data to populate the web page. But that's very simple. Like there's no other functionality that we're doing beyond just rendering those activity feeds. So if we have a more complex API, well, then we might use something like this example that Michael Simons from the Spring Data Neo4j team put together, where we're using the Spring Data Neo4j integration along with this Netflix DGS, which I think is domain graph service, something like that. This GraphQL framework that Netflix open sourced that has a lot of this functionality for how to handle batching and caching to avoid this N+1 query problem. So this gives you a lot of flexibility over the shape and implementation of your GraphQL API. But what if you want to get up and running, much more quickly and auto-generate the GraphQL API that you want to work with? And this is where the Neo4j GraphQL library comes in. So this is a JavaScript library for building Node.js GraphQL APIs backed by Neo4j. And so the way this works is you write your GraphQL type definitions, and then that is then used to drive what the data model in Neo4j should be, and also auto-generates all of the CRUD operations for your GraphQL API. So all of the queries for reading data, for traversing the data graph, as well as mutations for creating and updating data. And then the other thing that it does that is really powerful is at query time generates a single database query, so a single Cypher query for any arbitrary GraphQL request. So this means that those resolver functions that we saw earlier that the developer was writing, those are auto-generated, so we don't have to think about how to write data fetching logic. Instead, that's all handled for us by the library. And there's functionality for extending our API with custom Cypher queries. There's also a built-in authorization layer as well. So really powerful for getting an API up and running. Here's sort of the minimum viable snippet, I guess, for how you would build a GraphQL API with the Neo4j GraphQL library. First, install some dependencies. So install the Neo4j GraphQL library, and then it has some dependencies on GraphQL, the Neo4j driver, and then Apollo server, which we mentioned earlier. So what we're doing in the code snippet here is pulling in our dependencies. We create some simple type definitions. So we have an article type. It's connected to a topic type. You can see here that we have this relationship. This is a directive. And directives are GraphQL's built-in extension mechanism. So saying that some custom logic should happen here. And we use this relationship directive to encode the relationship type and direction. In the property graph model that we use with Neo4j, every relationship has a direction and a type, which we don't necessarily have in the GraphQL model. So once we define these type definitions, then we just pass those and instantiate the Neo4j GraphQL class. We use a driver instance. This is the Neo4j driver to connect to our Neo4j instance wherever that lives. And then here we're using Apollo server just to spin up a server. And that's it. So we didn't have to write any data fetching logic that says, how do I actually resolve this data from Neo4j? Our API has all of these things added to it for the entry points, queries and mutations, as well as filtering arguments and arguments for pagination, this sort of thing. So then at query time, here, if I write a GraphQL query now that says find articles, the topics they're connected to, what other articles those topics are connected to, then at query time, the Neo4j GraphQL library is going to take this GraphQL query and translate that into Cypher. And it uses a feature of Cypher called map projections to project out and return just the data that is requested in the GraphQL query. So the data that comes back from the Cypher query exactly matches the selection set of the GraphQL query. Cool. Any questions at this point? So Rafal says the DGS framework, yeah, domain graph service, GraphQL server implementation for Spring Boot. Yeah, so I haven't used that too much. I don't do too much in the Java ecosystem, but I know that was open sourced by Facebook, and I know my colleague Michael Simons has been looking at using that with the Spring Data Neo4j integration. So if you use that ecosystem, that might be an interesting example to check out. Cool. We'll press ahead then. So maybe let's look at a full stack application to see kind of how the pieces fit together and what kind of benefits we have. So one example application that I've been working on the Neo4j live stream. So this is just a application that we live coded on the Twitch stream, is called GrandCast FM, which is like a podcast application built using GRANDstack. And there are 3 basic views in the application. So I can search for podcasts by title or description, something like that. I can then see a feed. So if I'm signed in, I can see a feed that is the most recent podcast episodes for the podcast that I subscribe to. And then I can see episode details for a particular episode, like the show notes, and I can play the file, and I can add that to different playlists, this sort of thing. So in React terms, I have basically these 3 components that are responsible for fetching data. And with GraphQL, I'm able to attach my data fetching logic to the React component. So here are the GraphQL queries that I'm attaching to my React components to do podcast search, to show the episode feed for the currently authenticated user, and given a specific episode, show me the episode ID. One thing you'll see here that we didn't talk about before is we're using GraphQL variables here in these queries. So these GraphQL variables, the values for these are passed along with the query. Similar in Cypher, how we have parameters. So then each one of those components has its data fetching logic, which is running that GraphQL query, gets back JSON data then that component then knows how to handle to render the view. And because we're using GraphQL, because the client is specifying exactly the shape of those queries, we know exactly what data we're working with in the React app. Now on the back end, the data for those different components may be coming from different pieces of the data layer. So the search functionality, that's actually calling a REST API of the podcast index. So we're actually just searching for podcast by name in the podcast index REST API. For the episode feed and the episode details, that ends up being translated to a Cypher query and sent to the Neo4j database. So then when we deploy this, it looks something like this. So we're using the Netlify CDN for static content, so deploy our React app and the JavaScript for that. Then our GraphQL API is deployed as a Lambda function, and we're using Neo4j Aura for our Neo4j database in the cloud. So that's how the structure of this application, that's what that looks like once we've deployed it. Okay, so we've talked about GraphQL, this idea of being an API query language, not a database query language. We saw that it has limited expressivity, so we can't really do this idea of projections or aggregations built into GraphQL. And we saw that while GraphQL does expose our data, our application data as a graph, we can really use any backend data layer to work with GraphQL, not just graph databases. We hinted at a few of these things, but let's talk about the advantages that we have with GraphQL. So this idea of addressing overfetching, which is overfetching is sending more data over the wire than what a application actually needs. So if I'm, let's use the original use case that GraphQL is created for, which is the Facebook news feed. So if I'm showing you a list of news items for your friends, I don't want to show like all of the detailed information about the news item, like all of the comments for it that I'm maybe not going to show in the feed view. I only want to show the fields that I'm showing you in the feed view. So sending less data over the wire, and that's addressed by the selection set that the client sends specifies just the fields that it wants to be returned. And then this idea of underfetching, in underfetching in like a REST context with a REST API, if we have to make several round trips to the API to fetch all the data that we need for rendering a view in an application, well, that's going to incur latency. I want to just make a single request to the GraphQL API for all the data to come back. So in the newsfeed application example, I want to fetch maybe all of the feed items, but then also the profile image and the description of the profile for all the users that are going to be mentioned in the newsfeed. I want that to come back in a single request because in Facebook's example specifically, if I'm on a mobile app, a mobile device that has maybe a poor or slow network connection, I don't want to make a whole bunch of network requests. Another benefit is that we have a clear GraphQL specification, so we know exactly what is and isn't GraphQL. With REST, it's a little more fuzzy, and there's kind of a spectrum there. And then this idea of graphs all the way down, I think is helpful conceptually, but also practically. So conceptually, we're now thinking of our application data in terms of a graph, which I think is a very intuitive way to think of things. And that's actually how we often work with APIs, right? We work with APIs in the context of a relationship. So as the authenticated user, show me the blog post that this user has authored and the comments on them, right? That's all about relationships. So I think that's helpful conceptually, but then from a practical standpoint, it helps us to unify these disparate systems where we have data from lots of different services. And then for component-based data interactions, we saw an example in the podcast application where we were able to attach the data fetching logic into those components to render the view. Of course, there are some challenges with GraphQL. So a lot of the well-understood practices from the REST world don't apply. So things like HTTP status codes don't really necessarily have the same meaning. Error handling, caching is done a bit differently. How do we deal with exposing arbitrary complexity, the performance considerations there? All these sorts of things are challenges that come up, especially that N+1 query problem. There are tools and best practices that address all of this, like the Neo4j GraphQL library, for example, really addressing the N+1 problem and performance considerations. But these are some of the things that come up. So if we look at what are some of the common problems when you're building a GraphQL service, so having to maintain 2 schemas, one for your API, one for the database, mapping from graph to your maybe non-graph data layer, a lot of boilerplate code that we saw for sort of handling a request to the data layer, working with validating the results, and then this N+1 query problem. These were the things that we saw when we first started talking to users early on who were interested in using GraphQL, not necessarily specific to Neo4j, but that really informed a lot of ideas for and goals for the Neo4j GraphQL integration. So at a high level, reducing boilerplate, addressing developer productivity, making sure that it's extensible and performant. These were really the goals that informed what we wanted to accomplish in the Neo4j GraphQL integration. So this idea of GraphQL first development, taking the type definitions from GraphQL and using that to drive the database data model in Neo4j. So we're not having to maintain 2 schemas, one for the database, one for the API. This really helps a lot with data modeling. And then also auto-generating this GraphQL API. So adding the query mutation fields for all the different operations, adding things like ordering, pagination, filtering, the date, time, and spatial type. So all of this is sort of auto-generated for us just from those simple type definitions in GraphQL. Then to address that N+1 and performance problem, generating a single database query from Cypher, from GraphQL rather, so generating Cypher from GraphQL. So at query time, we have an arbitrary GraphQL request. It's translated into a single Cypher query, which the database then optimizes. That makes a huge difference in terms of performance, and also developers not having to implement all the data fetching logic, having that be generated for them. And this is one area that we haven't talked about yet, but I think is really powerful, which is this idea of using Cypher in your GraphQL schema. So we talked about generating basically CRUD, so create, read, update, delete operations, but what if we have some custom business logic? Well, we can actually attach Cypher queries in our GraphQL type definitions using the Cypher schema directive. So I said that schema directives are GraphQL's built-in extension mechanism. So it's an indication there should be some custom logic. And with the Cypher schema directive, I can write a Cypher query that is then attached or sort of annotated to a field in our type definitions. And instead of just trying to fetch that field from the database, we'll actually execute that Cypher statement as a subquery of the generated database query. So here, we're adding a recommended field that is a object array of businesses. So this is going to resolve a list of business nodes, and we are querying for kind of a collaborative filtering query. So given a business that we're resolving, what users are writing reviews of this business, and what other businesses are those users writing reviews of? Those might be good recommended businesses that you might be interested in if you're interested in this current business that we're resolving. So you can add all kinds of custom logic through Cypher in your GraphQL schema. So those were sort of all the goals that, that went into the Neo4j GraphQL library, which we have talked about already. Just kind of a reminder that we're not talking about querying the database directly with GraphQL. We're talking about tooling to build that API layer that sits between the client and the database. There's a demo here, which I'll just leave for an example, because I thought it would be interesting to go through the create GRANDstack app CLI. So let's save that for the end here. If you're interested in how the Neo4j GraphQL library is actually able to generate Cypher from a GraphQL request, well, what that does is it basically hooks into these resolver functions and looks at this object that's called the resolve info object. And the this resolve info object is passed into every resolver and contains a whole bunch of information about the GraphQL schema and the query and these sorts of things. I gave a talk at GraphQL Summit last year, the year before, kind of about this. So if that's an interesting area to dig into, that talk goes into a lot more detail of how those database queries are actually generated. Cool. So just for reference, some resources. The grandstack.io site is a good kind of just portal for blog posts, examples, documentation, that kind of thing. There is a Graph Academy training focused on the Neo4j GraphQL library now. And we just concluded with nodes a GraphQL focused hackathon. So if you're interested in seeing some example projects of things that people built, that's a good resource as well. I have been working on a book about GRANDstack. It's mostly done now. I'm working on the final chapter now, but there's a free version sponsored by Neo4j at grandstack.io/ebook that you can get I think it's like a 3 or 4 chapter excerpt you can download for free. So if you're interested in reading more about that, that's a good resource as well. And then I mentioned the Neo4j live streams earlier. This is, I think, a fun resource if you want to follow along or just join as we live code some GRANDstack applications. We've built a real estate search application, a travel guide, we built a podcast application. I don't know what we'll do next, maybe something with that news graph data. Yeah, cool. So those are some resources. So what I thought would be fun to do now is go through the create GRANDstack app command line tool, which is the GRANDstack starter project. So we can see how we can kind of really quickly get a full stack GRANDstack app up and running. But before we do that, maybe pause and answer any questions or anything that we have. So I see one thing in the chat here about the 5 common GraphQL problems and how Neo4j GraphQL aims to solve them. Maybe we have new problems with GraphQL. So yeah, so previously, so in that article, we're talking about schema duplication, server client data mismatch, superfluous database calls, poor performance, and boilerplate overdose. Yeah, so I remember that blog post. We can go find it. I think 5 common GraphQL problems and how Neo4j aims to solve them, something like that. So this this blog post was actually kind of a response to another post that Sasha had written that was kind of looking at problems with GraphQL in general, or problems with building GraphQL APIs in general. And I thought the 5 problems that he pointed out, I think really resonated with me because that really mapped to what we were trying to accomplish in the Neo4j GraphQL integration. So I'll drop a link to this in the chat. And I think, yeah, I mean, I think that those problems are relevant today still, really, as you're starting to build a GraphQL API. And a lot of the GraphQL tooling in the ecosystem has really evolved to address these common problems that come up. So there's this class of GraphQL integrations, I'll call them GraphQL engines, which are like database integrations or query generators for GraphQL that I think address a lot of these problems, specifically boilerplate, performance, and schema duplication. I think are really the main problems that class of tooling tries to address. So I think then once you've sort of adopted a GraphQL engine, a GraphQL library that addresses those problems, then yeah, then it's often things like, how do I handle caching? How do I handle authorization? Those are sort of the next things I think are common to think about.
I have one, if I may.
Please.
Hey, William, very interesting. I come from slightly different background, but I think I have an interesting question for you. So imagine that you are exposing a GraphQL interface API, which allows you to query status of your operating system processes. So whenever you want to find out like who spawned whom, what is the thread ID, or what is the memory, those are the attributes, those are the relations. So you can maybe picture this already in your mind. And now this information is like very much real-time kind of information. It updates frequently. OS processes are started and shut down, memory fluctuates, and so on. So my question is there any way to sort of subscribe to a GraphQL result and then be kept up to date with ever-changing status of those attributes, values, neighbors, whatever is that you are interested in, pretty much in the same way as you would maybe subscribe to some topic on Kafka or RabbitMQ or whatever. So like more like a publish subscribe pattern, but in the context of a GraphQL query response. Is this feasible with GraphQL? And if so, can you point me to some resources?
Yeah, so GraphQL has a concept called subscriptions. So we talked about this one. It's maybe a good one to look at. Maybe this one. We talked about the entry points for a GraphQL API being either a query or a mutation. So queries being reads, mutations being write operations. But there's a third group of entry points, which is the subscription type, which is, as you say, kind of like GraphQL's pub sub mechanism. And so what it allows you to do, let's see if we can find an example here. Maybe this one has some examples, but basically, yeah, here's the client side. So what we do is we say, subscribe to this query, and then I can express the selection set. And then typically this is done over like a WebSocket or something like that, where the client is just listening then for events to be published from GraphQL. But the JSON payload will match the selection set that is defined in the query. So here in this example, they're looking for like as new comments are added. And then you have in the GraphQL server implementation, you have the ability to just implement sort of whatever pub sub implementation you choose to use. It's quite decoupled from the actual GraphQL specification, really. This is the Apollo GraphQL example, which has, I think, a WebSocket implementation. It sounds like in your use case, it doesn't really make sense to have like a persistence layer, at least for kind of the operating system state, and rather just have something that's watching for changes and just publishing events in your case. So anyway, to answer your question, yeah, subscriptions in GraphQL are, I think, what you would be interested in looking into there. And you have lots of different ways for implementing that. Subscriptions in GraphQL is really just kind of part of the specification and defines what you can do, and then it's kind of up to you to implement that.
Thank you. This was very helpful. It does answer my question. I don't have any other. Thank you.
Cool. Cool. Any other questions? If not, then we will run through the Create GRANDstack app for a few minutes.
Okay, I have some problem with internet connection, but I'm now returned. So, anybody have some question for Will now or not? Okay, so thank you very much, Will, for the collection. It was very interesting, and I reckon that for a lot of people will be introduction to prepare own project using GRANDstack. So I have two questions, which will be typical for people who start journey with GRANDstack. So our meeting is a good place to ask them. When and where you recommend using GRANDstack in projects, and where not? We have a participant our meeting when people ask when using GraphQL and where and why not. So it's similar ask when we use main stack, min stack. So for GRANDstack is a typical question in my opinion. So what do you think about this?
Yeah, I mean, I think that GRANDstack is, and the tooling around it is really meant to be optimized for new sort of greenfield projects, full stack applications, getting you up and running quickly, like with an infrastructure that is scalable and performant and extensible, but really getting you up and running quickly. So if you have some idea for a new project or something like that, I think that's a really great place to start with GRANDstack for a full stack application. Of course, there are certain features of an application that can take advantage of some of the benefits of the performance of like Neo4j specifically, or some of the benefits of GraphQL. But I think in general, it's really looking at new projects that you have rather than trying to maybe introduce a component of GRANDstack into an already existing architecture. I think some of the tooling is maybe not optimized for that sort of thing. But anywhere where you have an application that has connections in the data. So like we looked at the podcast example where users have playlists have podcasts. We can give recommended podcast episodes given a user's search history, these kind of things. So I would say where you have connections in your data, but also where you want to add some, maybe like smart functionality, such as like user personalization or this kind of thing.
Okay, and second questions, how will be look a GRANDstack future? What is the planning to improve GRANDstack to become popular more nowadays? So how you look this?
Yeah, so I think a lot of the really interesting part of GRANDstack is this Neo4j GraphQL integration. And this is the Neo4j GraphQL library. This is where a lot of the functionality of GRANDstack lives. So all of the cipher generation, adding the cipher directive fields for adding custom logic, that's all handled by the Neo4j GraphQL library. So I can talk about some of the features and functionality that is being added to the Neo4j GraphQL library, because I think that then adds a lot of interesting things to GRANDstack as a whole in the context of a full stack application. But those things, one of the more recent things is authorization, which we didn't talk about today. Here's kind of an example where we can add these authorization rules to our GraphQL schema. So we can say that only the author of a blog post should be able to edit it. Only someone who, follows a user should be able to see that user's updates, these kind of things, these kind of rules. That allows us to get going with authorization rules in our application a lot faster, which I think is really powerful. So that was a fairly recent addition in the new version of the Neo4j GraphQL library. But your question was about going forward, what's coming. I think one of the more recent things that folks have been asking for is support for relay and the relay connection type. So this is not core to the GraphQL specification. This is kind of like an extension of GraphQL, and that is the relay. Let's see. Relay specification. right here, that kind of defines cursor-based pagination, but it also defines kind of a model for working with relationship properties in the graph. And so this is coming very soon to the Neo4j GraphQL library, which will introduce some concepts from Relay and will also have a better model for working with relationship properties in the graph. So this one I think is really exciting. I think the GraphQL ecosystem has kind of evolved in sophistication in the last few years. And I think Relay, so Relay was used internally at Facebook and had a lot of like best practices kind of built in. And I think that now the sort of public version of the GraphQL community outside of Facebook is seeing a lot more value in Relay. So because it addresses a lot of the common problems that come up with GraphQL from the client side. So anyway, I'm excited to see support for that and some concepts from Relay coming to GRANDstack as well. So that's probably the most exciting one.
Okay, so do you think GRANDstack is a future for a full stack developer or not?
Yeah, I mean, I think that it's really taking a lot of the best in class technologies, combining them together, right? I mean, we see that GraphQL is growing in adoption in general, right? And there's lots of different ways to build a GraphQL API. I think that GRANDstack is a good answer to the question of not only how do I build a GraphQL API, but how do I build it in the context of a full stack application? I certainly think that Neo4j is the best backend for a GraphQL API just because of the symbiotic relationship there. You get a lot of benefits from using a graph database as the backend for a GraphQL API, both in your data modeling and sort of mapping graphs in the API, the application data realm to the backend realm, and then Neo4j being optimized for the kind of nested queries that we end up writing in GraphQL. So putting all those together, yeah, I definitely think that GRANDstack is the best way to approach full stack development for a lot of folks.
Yes, devs are used to relationship, so it may be hard for them to give up SQL for Neo4j. Okay, so any questions for Will? Not see. So thank you once more, and I'm looking for topic for our next meeting in which we can talk more about GRANDstack or not only. So thank you very much for your time. Thank you for your presentation and the materials which you prepare for us after meeting. So see you after holidays. Now we have a time to relax, to in Polish odpoczywanie i picie piwa. So
great, thanks for organizing and thanks everyone for joining.
Are there any like events, any conferences, any meetups, whatever you call it, but something which is happening into 2021 around the topic of graphs and exploring graphs and visualizing graphs? What I am very much interested in is some tooling on the front-end side, which given some common API, some common GraphQL specification would be capable of providing a more interactive interface to querying the graph database behind whatever GraphQL API there is. In other words, imagine that those nice pictures that you had in your presentations, which represented nodes and edges in the graph, that this is like an interactive visual interface where you can actually click on those nodes and maybe see some attributes associated with a node, or maybe expand some in some direction, which would then load in more neighbors or whatever. do such things exist?
Yeah, and here maybe it's worth going through a quick demo of the GRANDstack starter project, and I can show you some of that functionality if we have a little bit more time. Oh, I stopped sharing my screen, and now looks like I don't have permission for screen sharing anymore.
Okay, 1 second.
But you asked about events specifically. So on that front, just last week we had a online developer conference called Nodes, which I'll share the link to here. Let me find the chat again. Here it is. Which had, there's a ton of content. We had, I think, 5 tracks covering lots of different things, including visualization, which you asked about, and GraphQL that you asked about a little bit. So that might be an interesting resource to check out some of these talks. This was just last week, so the recordings are available there. That's the last big Neo4j graph specific event. There are a couple of other GraphQL conferences coming up, I think in the fall as well. But let me run through the GRANDstack starter project, and we'll take a look at some of the visualization tooling that's available for Neo4j as we go through this, since you specifically asked about that. This should just take a few minutes. But one of the things we can do is run this create GRANDstack app command line tool. So let me make this a little bigger. And what this is an interactive command line tool that's going to help us provision a GRANDstack project. So I can go through this. I just run a single command, npx create GRANDstack app, and then the name of the project I want to create. And there are a few different front-end options I can choose from React, TypeScript, Angular, Flutter, or just the API. We'll do React, install the dependencies. We don't need a Git repo. And then it's telling me to go provision a Neo4j instance. Let's use Neo4j Aura. So Neo4j Aura, this is like the Neo4j hosted database as a service, but there is a free tier that I can use. So I'm already signed in. Let's create my graph, create a free tier database. So this will take a couple of minutes to provision. Oh, here's my password. We'll need that for later. Let me save that somewhere. Yes. Okay, so this is going to provision me a Neo4j instance in the cloud. So we'll go back to our command line tool. And okay, it's going to ask me for the connection string for Neo4j. So I'll have to wait just a little bit for this to get provisioned to give us the connection string. But while we're waiting, what I want to show you specifically about visualization and these sort of interactive visualizations that you asked about is Neo4j Bloom. Have you seen Neo4j Bloom previously?
If this is part of the standard web interface of Neo4j, then maybe I did, because I think this is the standard tooling for Neo4j, isn't it?
Sort of. Well, it's not part of Neo4j browser. So Neo4j browser.
Okay, so I mixed those two. Mm-hmm.
Neo4j browser is specifically meant for, think of it as like a Cypher query workbench. So I have to know Cypher to get anything useful out of Neo4j browser. I can have these very small scale graph visualizations as a result of a Cypher query. But Bloom is a different application. It is available in Neo4j Desktop. It's also available in Aura, which we'll look at in a second, but it gives us a much more like low-code interactive way to work with the graph without having to know Cypher. I can configure it, give it to an end user analyst, this type of thing. So that's what I want to take a look at once this provisions, but it allows us to do sort of right click on a node and expand a certain set of relationships, or to sort of filter for kind of a natural language query that I can type in without having to know Cypher. It's really good for something that you would give to like an analyst. I know it's very popular in financial institutions for fraud detection, and as part of kind of a Neo4j solution where maybe you have graph algorithms running in Neo4j that are flagging potentially suspicious transactions, and then the fraud investigative analyst will go in Neo4j Bloom and actually visually look for patterns specific to that flagged transaction to sort of verify whether or not this actually is a suspicious or fraudulent transaction.
But this would require like the standard Neo4j API, or would this actually hit some GraphQL API first?
So it does not use GraphQL. It's specific to Neo4j, but behind the scenes, it's generating Cypher queries.
So maybe being a little bit fresh to the topic, may I restructure my question, and maybe you will actually lead me a little bit more in the right direction. So again, this operating system processes example, let's say that the use case is I want to build a visual dashboard, pretty much like the Neo4j Bloom tool that you just showed us, which would visualize operating system processes and allow me to explore it in an interactive way. And I would like to build such tooling with minimal effort. So by which I mean like reuse whatever exists. Like if this is Neo4j Bloom that I can take and use as is, fine. What would I need to build in order to provide this translation layer from the operating system, bash script, whatever, which would pull in information and then translate it to whatever Bloom consumes as an endpoint. So I hope that you sort of get what I'm trying to describe here. And how would you approach such project?
Yeah, that's an interesting one. So Bloom has a lot of that end user visualization functionality that I think would be useful for what you're describing. It queries a Neo4j database. So where you have your sort of operating system state, to make that work with Bloom, you would need to import that into Neo4j, and then Bloom would query that Neo4j database to give you that interactive graph functionality. Another approach would be to build a more bespoke graph visualization application in maybe like a React application or something like that, that's querying and interacting with your GraphQL API, and then you don't necessarily have a persistence layer because you're just sort of inspecting the state of the operating system, and your GraphQL API is interacting with your React application. I'm not aware though of kind of a suite of tools that gives you this kind of interactive graph visualization specific to GraphQL. I think there are some things like charts and building dashboards and this kind of thing, but in terms of like an interactive graph visualization specific to GraphQL, I haven't really seen anything out of the box. There's sort of the components for these things that of course you can kind of assemble and build, but that's probably the way I would approach it. Actually, is probably put together some visualization tooling in like a React application or whatever front end that is leveraging the GraphQL data, and then maybe not even have a persistence layer and leverage the GraphQL subscriptions. That's just subscribing to events changing in the operating system.
I was hunting for some chart library which would visualize what I see Neo4j Bloom does visualize for years. And the closest I got was the Netflix Visceral, which they released 4 years ago. It was WebGL canvas rendered animation of traffic in microservice architecture of Netflix distributed systems. And this has been open source as a React component. So I have embedded this into my front end, and exactly the approach you just described. It is the one I took. So React application, embedding this WebGL canvas, and then connecting it to some endpoint that I exposed, just to feed it with the objects. I was hoping that maybe, given how long we have GraphQL and Neo4j used in many places, that maybe you are aware of some charts that are there and are easy to sort of take off the shelf and use as is.
Yeah, specific to GraphQL, I haven't really seen much kind of out of the box. Really, I think that's kind of a missed opportunity for tooling, perhaps. I did paste in a link. Maybe you've seen all of these, but this is the Neo4j developer blog. These are all of the blog posts related to visualization that touch on lots of different tooling using with graphs and Neo4j. So maybe something in there is helpful.
Thank you. This is very helpful. Thanks again. Yeah.
Great. So let's finish going through our example here. Our Aura instance has spun up, so I'm going to copy the connection credentials, paste those in here. The user is Neo4j. I saved the password somewhere. Let's find it. Here it is. There's the password. Okay, and so now what this is going to do, this is now going to download the latest release of the GRANDstack starter project, which is this GitHub repository. This is where the code lives, and it is like a business reviews application, kind of a template for something like that. And so while this is downloading and installing dependencies, let's jump into Neo4j and we'll load some sample data. So this is Neo4j browser, which we said is kind of like a query workbench for working with Neo4j and Cypher. So very much a developer tooling. And this is the Neo4j Aura instance that I just spun up. So there's no data in here, but I'm going to run one of these :play commands. These launch these interactive browser guides. There's one specific for this GRANDstack starter project app. So I'm not sure why it's complaining. Oh, our query has the eager operator. That's fine. It's just a simple query. So this is loading some sample data from a CSV file. So businesses, users, reviews, and categories. So I load that in Neo4j browser, and then I can say like, find all of our nodes and return those. And I can kind of work with this in Neo4j browser, like visually, but I have to write some Cypher queries, so that's not great for all audiences. And so we were talking about Bloom. So let's launch Bloom. So this is a separate application that is really, and again, this is not specific to GraphQL. This is just querying Neo4j directly. But Bloom is really cool for these interactive explorations and analysis of the graph where maybe I don't want to write Cypher, or it's not for a developer audience, like that analyst use case we were talking about with the fraud detection. So with Bloom, we have this idea of a perspective. So we can configure and style the visualization. We can add custom search phrases that map to Cypher queries. I'm just going to generate one from the data. And so right off the bat here, I can say, show me review that are connected to businesses. You can see it starts to kind of autocomplete based on just what I'm typing here and give me different options visually. So let's bring in this path. So show me businesses that have reviews that are in a category. So then I can kind of zoom in here. Here's a market on front. So one business, I can view detailed information about it. There's nothing else to expand. Here's a review. This one I can expand to see who wrote it. So this user Bob wrote this, and I can expand out from Bob. He just wrote a couple of reviews. But anyway, there's lots more that I can do with Bloom, but you can see I don't really have to be thinking of Cypher. I can configure this. I can style these so that if I run PageRank on this, I want the nodes with the higher PageRank score to be larger. If I ran a community detection algorithm and I want to color them according to community, I can do that as well. So
this is absolutely amazing. Thank you.
Cool, and this is available in Neo4j Desktop. You see that there's a little like open in drop down like this. You have that in Neo4j Desktop as well. So you should see that in there, or in Aura as well.
So I could also work with a snapshot of my data set because although data describing operating system processes and dynamics between those is a live kind of data, it changes, but it would be equally interesting to take a snapshot of a system, upload it to Neo4j instance, or as you say, Neo4j desktop instance, which I'm running locally, just for the sake of running this visualization on top of this data set, just to explore it. And this would be super useful. Thank you. Thank you again.
Yeah, absolutely. So let's go back to our GRANDstack app. Okay, cool. So this is done installing our dependencies. We can go into krakowgraph directory and just do npm run start. And this will take a while. So it started our GraphQL API, so we can do that. It's also building the React application, which takes a little bit longer, but here's our GraphQL API. And let's make this a bit bigger. So we can see we have users, businesses, reviews, categories. You can search for all the businesses, give me the name, address, their reviews, and who wrote the review, right? So we can query that using GraphQL. That's great. Let's let's go to another tab. I'm just going to open this up in VS Code so we can take a look at the code. Yes, I trust the author. I hope so. Okay. So if we look in the API directory at the schema.graphql file, so this schema.graphql file, these are our GraphQL type definitions. And you can see these type definitions map to the sample data that we created in Neo4j. We could have also created these through the GraphQL mutations. There's a seeddb functionality as well. But you can see here we have a few of these Cypher directive annotations where we're computing like the average stars for a user's review. We have recommendations for a user based on this sort of collaborative filtering query, looking at businesses that they've reviewed that they haven't visited yet. That might be a good recommendation. But what I want to do is change this to show us the generated Cypher query. So I'm just going to add here to set a environment variable. I think this. So this is just going to set an environment variable when we run this to turn on debug mode so that we can see the generated Cypher queries. So I think that's kind of interesting. Cool. So now, here's our GraphQL API. Let's run a simple query here. So just show me all of the businesses and return the business name. Now, if I go back here, let's make this a little bigger. So this is our server output. here we can see the generated Cypher query. So it's saying match on, oops, our React app started up and logged some output. That's why that moved. So this is saying find all the businesses, return just the name. So using this map projection functionality in Cypher to return just exactly what we've requested in the selection set. But now if we request also the reviews, let's add the user, we run this query. Now we can see that the generated Cypher query looks a bit different. We use this pattern comprehension functionality. So these Cypher queries end up being a bit different from how you might write them by hand. You would typically write out like the pattern in the match clause, but there's a feature in Cypher called pattern comprehensions where I can combine those with a map projection in this return clause and actually have the traversal pattern specified in the return clause. This is a lot easier to generate just by iterating through that selection set. But anyway, that's the GraphQL API. And then if we look at the React application, it's kind of like a dashboard view for giving us some information about these business reviews. So I see the rating distribution, I have 4 users, the recent reviews, and then a form that I can search for users by name. I can order this table by name, this sort of thing. So just kind of a boilerplate application to help you get started with GRANDstack. So now we can kind of modify the front end code and the schema based on the application we want to build out. And this includes kind of all of the starting point and a lot of the boilerplate for things that you don't necessarily want to configure every time you're building a new application. So anyway, that's useful to just kind of play around. And again, this was just this npx create GRANDstack app command line tool. I won't go through more of the React code. I'll leave that for a home exercise if anyone is interested in playing around. But basically, these React queries that we can see, or these GraphQL queries we can see in the logs here, these are run by the different React components as those views are rendered, and those GraphQL queries are attached to those components. So we've embedded our data fetching logic with our React components, which is quite a nice pattern for working with React. But anyway, I'll leave modifying that as an exercise if you're interested. But anyway, just wanted to go through and sort of show, in my mind, I think that's kind of the best way to get up and running with a new GRANDstack app with that create GRANDstack app command line tool.
Okay, so any questions from others? No, so thank you very much, very much, Will, for your presentation, for your examples, for prepare simple use cases, simple step-by-step how to run GRANDstacks local using Bloom, using Aura, and how works with GraphQL with Neo4j. So we are very happy that we have this person who have a lot of knowledge about GRANDstack, about graph and about graph databases, about graph technologies, and using this in environment production environments. So I'm sure that this meet was a better than game Polish national teams versus Sweden. Well,
it depends on who wins, right?
Okay, now is 2 for Sweden, 1 for Polish. So better was be here, not before television. So once more, thank you. I wish a great holiday for everyone with graphs or without graphs. So thank you very much and see you after holidays.
Cool. Thanks,
Great
folks.
stuff.
This is fun. Cheers.
Great stuff. Thank you.